I'm a physicist, but I study the ocean, and that probably sounds like a bit of a strange combination, because normally when we hear people talk about the ocean, we hear about the biology, the whales and the dolphins. We might hear about the chemistry when it comes to perhaps pollution or ocean acidification. But I am here to tell you that the real story of the ocean is in the physics, because our global ocean is an engine, a blue machine. And the way that blue machine turns influences all of our lives. You can see its markers through our culture, through our history, through how almost everything on our planet works. And I think we should talk about the ocean more. But we don't really look at it. And that is partly because it's hard. You know, on a spherical planet, we have to choose. If we're going to unwrap it, we have to choose how to do it. And this projection here, this is a way of looking at the ocean. It's sometimes called the world according to a fish. It occasionally pops up on social media. And this is the global ocean, but it's unwrapped in a way we don't expect. And it's called the Spillhouse projection. And the guy who came up with this projection in 1942 said something really profound. He said that to see the land, we always cut the ocean. But in order to see the ocean, we must cut the land. And that's what this model is. So it's unwrapped. And you can really see when you look at the ocean like this, and those gold arrows are currents that move around the world, you can really see that this is all connected. We know, everyone's heard, it covers 70% of our planet. But this is a connected entity. It surrounds everything. And it's kind of strange that we don't look at it more. So this is a very, very famous photograph for the Apollo 17 mission, 1972, when they were on their way out to the moon for the last time that humans went to the moon. They had a relatively unusual, it was the first and last time so far that it had happened, where as they were moving away from the Earth, they were positioned almost directly between the Earth and the sun. And that meant they could take this picture where the full disk of the Earth is illuminated. So there are no shadows. And you can really see, it was called the blue marble, because you look at this and not only do you see a fragile planet hanging in space, you really see how, we heard from Andrew how vast the cosmos is, and we're this precious little ball of atoms that's got all this amazing stuff on it. But you can also see that we are blue. And so it was called a blue marble. And so we've been calling ourselves a blue planet for 50 years. And yet we don't really look at that blue. And so there's a big question about why that is. And I think part of the reason for it is that the ocean, this ocean engine, it does things that are very large and very small and very fast and very slow. And there's all these different perspectives on it. And so it's really hard to say what the ocean is in 1 or 2 or 3 sentences, because it's so many things. It's such a rich and complex system. So I can't tell you about all of the ocean in the next 12 minutes. So what I'm going to do is pick out 3 stories. But all of them are about things that we might recognize, animals or history or culture. But what I want you to hold, and each of them illustrates something about the physical nature of this engine. But what I want you to hold in your head while I'm talking is that these are just 3 stories, and there are hundreds, thousands of ways of looking at the ocean. And it's such a rich environment that to really hold on to what it is, you have to think about it in all these different ways. And that's the brilliance of it. The more you know about the ocean, the more you see how it's affected us and how actually everything on this planet is built around it, the richer and the better it gets. So let's get started on the stories. So the first thing is the ocean has structure. It looks like it's just water, but actually that water has different characteristics in different places. And it's just one example of that. This is a Greenland shark. It's a famous animal partly because it's one of the longest lived animals on Earth. It's thought to live to 450 years old, doesn't reach sexual maturity till it's 150. But it lives life very slowly. It moves very slowly, a few centimeters per second. I don't think anyone's ever actually seen it hunting, but it's found with the remains of fast animals inside it, so it must be an ambush predator. But the reason it can live slowly is that it lives in really cold water. And we know cold slows things down, and so it just lives its life very, very slowly in the cold and the dark. Actually, most of these are blind because they have a kind of worm in one of their eyes. This one doesn't. So if we look at a picture of the North Atlantic here, you can see the colours denote the temperature of the water at the surface. So the red colours around the tropics here, we've got nice warm water, 30 degrees. And then up towards Greenland there, you can see the dark blues, and that's much colder water. So a Greenland shark normally would live its life up here in the cold water. That's where you find cold, slow animals. But back in 2013, there was a ship in the Gulf of Mexico that was studying, and the Gulf of Mexico is here in the warm bit, and they were studying the outcome of the Deepwater Horizon oil spill. So they were doing ecological sampling to see what was there to compare before and afterwards. And so they put a line down, 3 kilometers down into the ocean, because the Gulf of Mexico is very deep, and they pulled that hook up, and out onto deck came a juvenile Greenland shark, warmer in life than it had ever been in death, warmer in death than it had ever been in life. And this, it was obviously not expected. This is not where Greenland sharks live. So the researchers were, they paid enough attention to put out, a few tweets about it, but they weren't that surprised. And the reason they weren't that surprised is that they knew something about the anatomy of the ocean that we don't often talk about. And that's this, that over most of the global ocean, this is the pattern. There is a warm lid of water that can be tens, maybe 100 meters thick, that sits on the top, and then underneath that, there's much cooler water, and you can have different layers within that. But the big picture is this warm lid on top, and there's cold water underneath. So down there in the Gulf of Mexico, where that shark was found, even though the surface water was 30 degrees C, the water it had come from down below was 4 degrees C. So it would have been a bit warm, but not too hot for a shark of that type. And the lesson here is that the ocean has structure, it has anatomy. Even though it's all water and there are no hard boundaries, that water can have different characteristics in different places. So that's one thing. The ocean's got anatomy. Now, we often hear, there was this famous film that Jacques Cousteau made, you may remember, that's probably, it's the sort of thing that was extremely famous at the time, The Silent World. This was the world's introduction to the ocean. Back in 1956, Jacques Cousteau was one of the inventors of scuba diving, and he then developed underwater cameras, took them down, showed the world what was down there, showed people fish and turtles, made this film that was the ocean's introduction to the world. And then he called it The Silent World, which drives me nuts because the ocean is not silent. And he must have known that. He was a free diver before he was a scuba diver. And the reason that it's a real, hooray for introducing the ocean to the world, but, boo for doing it like that. Because in the ocean, the roles of sound and light are switched. So we know that up here on land, if we want to see something a long way away, perhaps the moon, perhaps the person down the road, perhaps the rest of the cosmos, we use light. We know light can travel a long way. And sound does not travel a long way. We take it for granted that, during the interval, some of you were having conversations over there and some over there, and you probably couldn't have heard each other. Sound doesn't travel very well and very far. So for us, sound is a short-distance messenger. But in the ocean, it's the sound that's the long-distance messenger and the light that only travels short distances. So to call it the silent world just completely ignores all of that. And really, sound is the messenger that connects the ocean together for the life that's inside it. And as just one example of that, I would like to show you this. This is from the Natural History Museum, down in their collections. And what it is whale earwax. Now, the reason that whales have earwax is that they evolved from creatures that had ears that were not dissimilar to ours. Inner ear, middle ear, outer ear. They were land mammals, so they had ears that stuck out the side of their heads. And once evolution took those animals into the water, first of all, the outer bit caused a lot of drag, so evolution got rid of that. But secondly, when you're underwater, and this is true for all of us as well, if you put your head under a swimming pool, actually this bit of your ear isn't much use to you anymore. It doesn't take sound inside because the sound is in water. What's happening is the sound comes in, it hits your jaw and the bones of your skull, and it's bone conduction that then takes it inside your head into the ear. So that was how the whales started to hear, through their jaw. So basically, they closed over the outside part of their ear, but the middle ear, evolution isn't particularly tidy, so the tube stayed there, and the earwax was still made. It just didn't have anywhere to go. So it kind of was produced and just pushed up the tube, and it got stuck, right? And so all these layers of earwax build up over a whale's life, and that's what you're looking at, a whole whale's lifetime written in its earwax. And if you go to the Natural History Museum, this is their life-size model of a blue whale. If you look just up behind its eye, behind the folds of its eye, in the model, there's a very little dimple, and that is where the ear used to come to the surface. And there it's on the model. Anyway, so what a load of researchers did is they realized, between the Natural History Museum in London and the American Museum of Natural History, they realized that they had lots of these earwax plugs, and they knew when the whales had died, because museum curators are very organized like that. And they did this brilliant thing. They lined up the plugs of whale earwax going back 150 years, a global record of what was going on with the whales. And they measured one particular thing. They measured cortisol, the stress hormone. And this is what the plot looks like. So you can see 150 years along the bottom, 1870 there, going along to 2020 over here. And that black line, so the black axis here, that's the cortisol. That's how stressed global whales are at different periods in time. And then the blue on the side here, what's the most stressful thing that happens to a whale? Being hunted. So this axis here shows the number of whales that were being killed for commercial whaling. And you can see that commercial whaling makes whales very stressed. That when you get a big peak in whaling, you get a huge peak in whale stress. And it correlates pretty well, which is perhaps not surprising. But there's this period where it doesn't match up. So although this is the end of industrial whaling down there, that's when it was all banned. There's this period when this correlation goes away. And it's this period here that's in the shaded area. And that was World War II. And during World War II, you know, the humans were busy killing each other. You'd think the whales would be having a great time. But actually, you can see that whale stress goes up quite dramatically. And the explanation for that is that what the humans were doing, the bombs, the torpedoes, the ships, was filling the ocean with noise pollution. The whales couldn't hear. And sound was so important to them that if you filled their world with sound, they couldn't operate. They were really stressed. And so the importance of sound to these creatures is written in this earwax record. It's quite an extraordinary thing. And actually, if you follow that stress on to the modern day, we are again stressing the ocean. And you can see that in the earwax as well. So then there's one final thing. So we've got the messengers in the ocean, the sound and the light. I want to talk to you about tuna fish. So tuna fish are astonishing creatures. They are warm-blooded. They are very, very fast. This is a bluefin tuna. They're extremely agile. They've got incredible. They can travel a very, very long way. Basically, they can go wherever they want in the ocean to hunt. So there's hopefully you have a little bit of a picture in your head perhaps that the ocean has anatomy. It's got places in it. The water is different in different places. So if you're this kind of predator, if you can go anywhere in the global ocean to hunt, where do you go? So the whales, if we zoom in, the tuna, if we zoom in on a map here of the North Atlantic, the North American coast here, we know that off the side there is a current called the Gulf Stream, a warm stream of water that goes out into the Atlantic. But it's not just a smooth stream of water. That's far too simple for the ocean. The ocean's got better things to do than that. So if you look in, so here we've got cold water to the north of the Gulf Stream and warm water to the south, and the Gulf Stream's kind of moving through the middle across the Atlantic. And as it goes, what happens is it starts to wobble. And the wobbles can get bigger. And if a wobble gets really big, a whole little circle basically can spin off by itself, forming an eddy. And what that gives you, both on the north and the south side, is it gives you little packets of spinning warm water in the cold water to the north, and little packets of spinning cold water, floating islands that keep their own identity as they float round the ocean. And so the Gulf Stream is budding these eddies. They can be 50 to 100 kilometers across. They can last for several months, up to 2 years. And they're little packets of ecosystems. They carry their own ecology in them. And they're really special places. And so the tuna come here to hunt. They choose to travel thousands of kilometers across the ocean specifically to find this feature, not any of the other features, this one. And when it comes to who hunts where, you can actually see a difference. So the bluefin tuna, they like the warm ones that are going clockwise. The yellowfin and the big-eye tuna like the cold islands in the warm water that are going anti-clockwise. And the swordfish hang around the outside. So there's this astonishing thing of islands of water within water. And they are moving around the ocean, and animals are going to find them because they're predictable, because they know they're there. And the ocean is full of features like this. It's not just a random empty space that's a void that's sort of very, just all kind of mixed together. It's full of features. It's full of parts of the ocean doing stuff that then has an influence on what we do and how we live our lives. So, you know, back to this picture here. In next year, NASA, currently, the NASA, the Artemis missions are going back to the moon. And for the first time, humans will be far enough away from the moon that they will be able to look at this full disk again. So for the first time in 50 years, human eyes will see the blue planet from space. And this time, we have to understand that that color blue is not just a question, it's not just about it being a color. It's so important to our planet that this is a question of identity. This is who we are. And you know, the light that travels out from Earth and out into the universe, that's our signature on the universe, traveling across space, across the cosmos that Andrew was describing. And as it does so, it sends a message. And this time, when we humans are far enough from Earth to read that message, we have to really understand what it means. Because what we are telling the universe is that we are ocean. Thank you.
That was so interesting. So thank you a huge amount. Obviously, you mentioned Andrew Ponson in the first section, and obviously he talked about how we're not very likely to be living in a simulation. But after hearing that section about whales, I'm beginning to think maybe we actually are living, just because it was such this idea that whales actually came from land-based.
Yeah. They were small creatures about this big, about the size of a large dog.
Right.
Yeah, and they were walking around on land, and that's why all the mammals in the ocean, dolphins and whales, they all evolved from a land mammal that then moved into the ocean, which is why they have features similar to us. It's why they have to come to the ocean surface to breathe.
Yeah.
Their lungs are similar, and of course they have other adaptations. But actually, this is the way evolution works, right? You've got millions of years to play with.
Yeah.
Why not? If moving into the ocean is advantageous, get on and do it. So that's why there are mammals in the ocean. Yeah.
Wow, I had no idea. I mean, of course, you tell me that it makes a certain amount of sense. Although I do wonder what they were like. What would force them from the land into the sea?
Well, I wasn't there.
Yeah.
But
no.
well, I mean, you know, it's the nature of so evolution is a random process. That
Yeah.
if there's a small advantage to be taken, it's thought that they would have lived on the shore. Perhaps they started to see lots of fish. You know, it was an advantage for them to go and fish and come back to land. And after a while,
Right.
you're spending more time in the water than you're spending on land. And then there are no other mammals in the sea. There are plenty of fish and ichthyosaurs and things.
Sure.
But then you've got a niche, and then maybe that. And once you're in, then you get the very large whales. You can evolve a blue whale. You can evolve a dolphin. Yeah. You've got a route out into all these different.
Incredible. We started with startups in the beginning, and they often talk about pivots in their business model, and this is an interesting pivot into the ocean. The other fascinating thing. I mean, not to sort of overfocus on the whale bit, but the stress in earwax graph was also fascinating, and the idea that they would be stressed out due to all the sound pollution, if you will, during World War II. But you didn't actually talk that much about, obviously, the whole whale death thing is gone to, I guess, near zero because of the banning of commercial whaling. But obviously you have this huge stress thing going the other way, and as far as I know, there's no there's no World War II happening. So what might be going on?
So really, I mean, the story of that thing about sound in the ocean is a story of unintended consequences, right? You know, humans were making sound in the ocean long before they knew they were making sound in the ocean. Yeah. And so it's the same with a lot of the things that we do in our industrial life. Like, we're having effects in the ocean long before we're capable of measuring those effects. And really, I think, the message for businesses and for, the challenge for all of society today is to look at how nature already works and fit in with it. Mm-hmm. Because there are big rules about how the planet looks. Like, recycling is a natural part of the natural world, right? It just happens. It has to. We've only got so many atoms. They've got to come around again. So really, if you look at those natural systems and work with them, instead of trying to run up the down elevator and work against them, you're going to do much better. And the problem we've got now is that we've not been looking at it like that. We've just been treating the ocean as this kind of void. It's just emptiness. We'll just fill it up. There's nothing in there, which is nonsense, because it's doing all these things. It's just that they're so big. We live inside them. It's hard to see them. And so it is true that a lot of the creatures in the ocean are stressed, not just because of noise pollution, but also chemical pollution. Warming temperatures mean that they shift where they can live. Stresses from overfishing. You know, there are these things called, what that really is, that graph is these things called sublethal stressors. So individually, it's not going to kill a whale, but it is going to add, you know, it's a bit warmer, they can't quite find their food, it's harder to find their family, you know, it's just all very stressful, and that makes it harder for them to survive, and it makes them less resilient. And so the thing about the ocean now is that you have to look at, you know, people like having a void, it's very convenient, it's very beautiful, fine, but actually, the ocean is a very beautiful engine unless we start seeing what the water itself is doing, how it turns over, how the things that come from underneath provide things we take for granted at the surface. Unless we look at that, you know, we could cause a lot more damage. But actually, we do understand the ocean. I wrote a book about it, you know, as you mentioned. And the book is full of these stories, but really, I think what it does is build up a picture that then says, okay, now we understand. Now we can think about how to work with this rather than just treating it randomly and accidentally. We're not, you know, in the future, we don't want unintended damage. We also don't want any intentional damage. Sure. But we have to look at how it works and respect that and work with it and appreciate that sometimes big open spaces aren't just things for humans to fill. Yeah. You know, it's already doing something. We don't. It's not empty. It's just that it hasn't got us in it. And you know what? Maybe that's all right.
Helen, thank you so much.
Thank you for having me.